Let's see now how implementation inheritance breaks encapsulation. Suppose we have a dog class that has these two methods here. So there's a bark method that does system.out.println bark, and bark many, which uses a for loop to call bark many times. Okay. Now, to a user on the outside, I can say bark many 5 times, and I should get bark, 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 bark. And I don't really care how it's implemented. I mean, this is one possible implementation, but I have a certain behavior in mind. Now it's possible that later, let's say the Oracle company is maintaining the dog class. Maybe they decide, someone comes into work and says, let's switch these, right? So what I'm going to do is make the bark many method call println bark, and the bark method is going to call bark many 1. This will work exactly the same, and this change, from an outsider's perspective, there is no difference, right? I can call both of them, I'll never see a difference. So here's where inheritance causes trouble. Even though I may not even have the source code to dog, even though it's built into Java, I can write my own dog class. So maybe I write one called verbose dog. And what is verbose dog? Well, it's a method that starts off the bark many method by saying, as a dog I say, and then calls the bark method multiple times. So let's imagine, here's my hierarchy. I have a dog class, it has a bark and a bark many class. Verbose dog only overrides bark many, so it inherits bark from above. So the question is, if I do vd.barkmany3, where vd is a verbose dog variable, the question for you is, what does this do? So ponder that for a moment. What will it actually output? Okay, so we have to turn to dynamic method selection. And in this case, if we do vd.barkmany, the dynamic type of the vd variable is verbose dog, so we'll call this method. That will in turn call bark. And this .bark we see does not exist, so we'll turn to our superclass and we'll call bark. So we'll get, as a dog I say, bark, bark, bark. Now finally, the rub. Someone at Oracle decides, I'm going to switch these two methods. I like the idea of bark being here instead, the actual sound. So they changed this around. Now we already said that there's no way that an outsider could ever know, but here, perhaps maybe, something interesting happens. I mean, something does, so it's your job to figure out what exactly. So if now I do vd.barkmany3, I want you to consider this class and think about what happens. And think really hard, because I'm going to spoil it shortly. Okay. So in this case, we call vd.barkmany3. Its dynamic type is verbose dog. So this method executes. We get here and we say this.bark. Okay, what's the dynamic type of this? Well, it is verbose dog, so we'll try and call the bark method of verbose dog. It doesn't exist, so we go to the superclass. This bark method executes, and it goes this.barkmany1. What is the dynamic type of this? Well, the object in question is actually, its runtime type is verbose dog, so we call the bark many method with 1 as an argument. This in turn calls the bark method, which calls the bark many method, which calls the bark method, which calls the bark many method, and we get caught in an infinite loop. So what just happened there is that by allowing inheritance, in particular implementation inheritance, we now have a way to peek inside of what was otherwise a beautifully encapsulated class. There was no way to get in here, but we just showed we could. And in fact, it had dire consequences. We didn't change anything about our code. Someone else changed something they thought was safe, and kapow. Now, this doesn't happen in a practical way super often, but it does. And I think that philosophically, it's something that makes me nervous about implementation inheritance. It breaks encapsulation in just a really distasteful way. And there are benefits to implementation inheritance, but there are trade-offs because we run afoul of this terrible philosophical awfulness.